Greetings everyone. My name is Mayank Kejriwal and this is my submission for ELP project. I have made this project on simple over voltage protection circuit. We will go through the contents in the following order. First we'll introduce the topic, then we'll talk about the equipment used, then the circuit diagram and then the working and we'll conclude about the topics. There are many different ways to protect our circuit from over voltage. The simplest one is to connect the fuse at the input supply side. But the problem is that it's a one-time protection because as the voltage exceeds the preset value, the wire inside the fuse will burn and break the circuit. Then we have to replace the damaged fuse with a new one and make the connections again. Here, so in the circuit, we can use a zener diode and a bipolar transistor for automatic over voltage protection. This is done by two methods, that is zener voltage regulator circuit or a over voltage protection circuit using zener diode. We will use the second one, that is the zener voltage regulator circuit. It doesn't disconnect the output part when voltage exceeds the safety limits, but it will receive the less voltage than the zener diode. The equipment used in our circuit to make a zener voltage regulator circuit is as follows. We got one breadboard, one PNP transistor, one resistor of each 1 kilo ohm, 2.2 kilo ohm, and 6.8 kilo ohm, zener diode 1, and one connecting wires in the laboratory. A zener voltage regulator protects the circuit from over voltage and also regulates the input supply voltage. Circuit diagram for over voltage protection using zener voltage regulator is given here. The preset voltage value of the circuit is the critical value over which either the supply is disconnected or it won't allow any voltage above that value. Here, the preset voltage value is the rating of the zener. Like we are using 5.1 volt zener diode, then the voltage at output will not exceed 5.1 volt. We can see that the over voltage protected load is connected across one PNP resistor and a resistor of a PNP transistor and a resistor of 6.8 kilo ohms. We have a input voltage receiving from R4 and a zener diode is connected to the ground also. When the output voltage increases, the base emitter voltage decreases. We know that from our basic knowledge. Now, as the emitter voltage will decrease due to the transistor Q1, due to it, it will conduct less. And as the conduction of Q1 will decrease, the output voltage hence will maintain a constant output voltage. Hence, our circuit will give a constant output voltage due to which we can protect our device, that is load, where it will not exceed the required value but it can be used and reused every time again. The formula for output voltage is Vz minus Vbe, where Vz is the zener breakdown voltage, that is the breakdown voltage of the zener diode D2, that is in this case is 5.1 volts, and Vbe is the base emitter voltage, the voltage across the base and the emitter of the PNP transistor Q1 connected across the load. This circuit is also built using zener diode and PNP transistor. This circuit disconnects the output when the voltage exceeds the preset level. The preset value is the rated value of the zener diode connected to the circuit. We can even change the zener diode according to our suitable voltage value. The disadvantage of the circuit is that we may not find the exact value of zener diode. So choosing one will have to be the nearest reset to the preset value. When the voltage is less than the preset value, the base terminal of the Q2 is high, and as it is in PNP transistor, it turns off. And when Q2 is in off condition, the base terminal of Q1 will be low and it allows the current to flow through it. And when the voltage exceeds the preset value, the zener diode starts conducting, which connects the base of Q2 to ground and turns on the Q2. When Q2 turns on, the base terminal of Q1 gets high and Q1 turns on, which means Q1 behaves as an open circuit. Hence, Q1 does not allow the current to flow through it and protect the load from exceeded voltage. Now, we'll also consider the voltage drop across the transistors. It should be low for proper accuracy of the circuit. If we use a proper transistor, that is FFMT 718 PNP rated transistor. The working of this is as same as we have discussed in the previous slide. The reference which I have used to make this particular project is from Wikipedia, Circuit Digest, Microcontrollers Lab and ELP ROCUS. Thank you.